welcome to another WJEC A level physics question. This is the January 2010 Unit 2 question 6 on particle physics, which nowadays is in Unit 1. The question starts by telling us that the quark makeup of a neutron is up, down, down, and we've got to explain why only that combination is possible to give us a neutron. So we should know that the up quark has a charge of 2/3 e. That's given in the data book anyway. The down quark is minus 1/3 e. So if we put up, down, down together, we get 2/3 of e minus 1/3 of e minus another 1/3 of e, which is 0. So the total charge of up, down, down is 0. That's the same as the charge of the neutron, and that's the only combination of 3 quarks, because a neutron is a baryon made of 3 quarks that will give a total combination of 0. Next, we're told that the pi minus, the negative pion, has a quark makeup of down, anti-up, and is also a particle called the delta minus, which has got a quark makeup of down, down, down. And we've got to show that the magnitudes of those charges are equal. So if we do the pi minus first of all, so the pi minus is down, anti-up. Down is minus 1/3 e. Up is 2/3 e, so anti-up is minus 2/3 e. So altogether we've got minus 3/3 or minus 1 e. The delta minus, down, 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 is minus 1/3 e, minus another 1/3 e, minus another 1/3 e, again giving us a total of minus 1 e. So the charges are the same. Next, we've got to explain in terms of quarks why the pi minus is classed as a meson, but the delta minus is a baryon. So let's start with the delta minus. That's the slightly easy one. The delta minus is a baryon because it's made of 3 quarks. Baryons are always made of 3 quarks. Now, the pi minus, a very common mistake that people make when they talk about mesons is they say that it's made of 2 quarks, but we've got to be a little bit more specific here, and we've got to say that it's made of a quark and an antiquark pair. Examiners won't give you the mark if you just say 2 quarks. The next part of the question tells us that the delta minus is a very short lifetime, around 6 times 10 to the minus 24 seconds. It's almost always decaying into a neutron and a pi minus as given in the equation. We've got to show clearly whether or not the following are separately conserved in this decay. So we already know that the delta minus is down, 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 and we know that the neutron is up, down, down, and we know that the pi minus was the up anti-down, the down anti-up. So looking at up quark numbers, on the left hand side of this equation there are 0. On the right hand side there's 1 for the original u that we've got here, and a minus 1 for the u bar. So we've got 0 on the left and 0 on the right, and therefore the up quark number is conserved. Look at down quark numbers. We've got 3 downs on the left. On the right we've got 2 downs in the neutron and 1 down in the pi minus. So we've got 3 downs on either side, so down quark number is also conserved. We've got to give one reason for believing that this decay is not a weak force interaction. Well, we've got various options here. Well, first of all, the time is very short. It's far too short for the weak force. In fact, this is a time that's typical for the strong force. Also, with the weak force, we will find that neutrinos are involved, and there are no neutrinos in this interaction. And the final thing that we could say is that in the weak force or the weak interaction, we will find that there's a change of quark flavors. And here there are no change of quark flavors. So I'm just going to go for that option, but any of the others would also be fine. So no change in quark flavor. Question continues, part D. This time we've got the delta double plus It's a baryon, so it's made of 3 quarks, and it's got a charge equal to that of 2 protons. We've got to write down the quark makeup which it must have. So it must have up, 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 because if we have 2/3 of E 3 times, that gives us 6/3 or 2E, so hence the charge of 2 protons. The delta double plus decays into a proton and a pion, a pi meson, by a similar mechanism to that in part C, and we've got to determine the quark makeup of the pion. So what we've got here is the delta plus will decay into a proton and a pion. I'll just leave it as a pi for the moment, and we'll work out what it is in a moment. So the delta plus was down, down, down. The proton, we must learn, is up, down, down, plus the pion. So if we look in terms of up quark numbers, there are none on the left, so there must be a total of 0 on the right. So the pi must have a U bar, so it can cancel out the U in the proton. And if we look at down quark numbers, we've got 3 downs on the left, only 2 downs on the right, so it must also have a D. So we've got U bar D as its composition. Thank you for listening. Please remember to like and subscribe, and feel free to add any comments below the video. Goodbye now.